Welcome. Today, we're exploring the critical shift from standard software engineering to agentic engineering, and why moving beyond vibe coding is essential for building production-grade systems. Vibe coding is great for prototypes, but in production, without deterministic tools and proper feedback loops, it inevitably creates technical debt and untraceable bugs. Notice the continuum. Traditional dev is entirely human-crafted. Prompting adds stochastic generation, while agentic engineering wraps that stochasticity inside deterministic boundaries. An agent is a triad. Perception observes the code, planning structures the changes, and tool execution safely applies them. In large codebases, naive prompt and paste hits a wall. This is exactly why organizations are adopting agentic frameworks that enforce determinism. Traditional software is linear and rigid. In contrast, agentic systems define objectives and sandboxes, letting the agent iterate toward the solution. Here is the core loop. The agent continuously observes the state, decides on an action, executes a tool, and immediately processes the resulting feedback. Notice how strict these tool schemas are. We enforce types and forbid unknown properties, ensuring the agent remains predictable. Production agents need two memory tiers: fast, ephemeral memory for the active task, and persistent knowledge graphs for architectural history. By wrapping agents in a finite state machine, we prevent invalid actions, like modifying code before verifying its dependencies. Avoid unnecessary complexity. Use single agents for simple tasks, and reserve specialized router-critic loops for high-stakes migrations. Match your architecture to your needs. Interactive agents require low latency, while asynchronous CI/CD agents have time for deep testing. A smart agent doesn't load everything at once. It maps the directory first, inspects symbol signatures, and only fetches files when required. Vector search is useful for fuzzy concepts, but AST parsing is strictly required for reliable symbol resolution and refactoring. To maintain model focus, use AST-aware chunking and prune stale outputs. This keeps your context clean and your results reliable. When it comes to patching code, whole file overwrites are dangerous and inefficient. Unified diffs can be fragile. Surgical match replace is the industry standard for reliable agentic editing. The feedback flywheel is essential. Compilers and linters act as teachers, instantly reflecting syntax or type errors back to the agent for self-correction without human intervention. We don't just execute tests, we parse the results. By isolating failed assertions and creating minimal reproduction scripts, agents can reliably verify their own bug fixes. Handling multi-file refactoring requires a structured approach. Agents must build a dependency graph, perform topological sorts, and execute sequential patches with verification at every stage. Tools like Warp Agent, Claude Code, and SWE-bench demonstrate key patterns, custom interfaces, strict security sandboxes, and deep integration with standard developer workflows. Standard unit tests evaluate code, but not agent behavior. For agents, we must shift to evaluating trajectories, tool selection accuracy, and adherence to security guardrails. SWE-bench has become the gold standard for evaluating agents. It uses real GitHub issues, requiring agents to pass both the fix and all existing tests to succeed. To get real-world performance data, build your own evaluation harness by mining your company's historical PRs, containerizing the state, and measuring success rates. LLMs can be non-deterministic. To manage this, we use PassKey benchmarking across multiple runs, pin-specific model versions, and set strict deployment thresholds. Use a tiered evaluation strategy. Rely on deterministic compilers as your hard gate, and use LLM as a judge only for subjective semantic and qualitative assessments. Security is non-negotiable. Always run agents in isolated environments, such as micro VMs or containers, with strict network egress filtering to prevent unauthorized operations. Agents have common failure modes like infinite loops or hallucinated imports. Implementing programmatic detection and recovery logic is crucial for production stability. Beyond sandboxing, you need a policy interception layer. This layer parses shell commands, blocks dangerous operations, and requires human approval for high-risk actions. Choose your model tier wisely. Use Cloud Frontier models for complex architectural tasks, and leverage local open weights for low-cost, air-gapped coding assistance. Finally, optimize for cost. By using prompt caching and routing simple tasks to cheaper models, you can make agentic workflows highly efficient and scalable. For local coding agents, choosing the right runtime is crucial. Ollama is unbeatable for quick setup, while VLLM handles high-throughput enterprise needs. Llama.cpp offers a great balance for local laptops. You can build a completely free, continuous bug hunter. This architecture parses functions locally, audits them with an open model, and automatically verifies fixes with tests, all behind your firewall. Maximize performance and cost efficiency with hybrid tiering. Use free local models for common linting and search tasks, and reserve cloud frontier models for complex architectural reasoning. Security is mandatory for enterprise adoption. Implement air-gapped operations, scrub secrets before prompts, use strict role-based access controls, and maintain immutable audit logs for compliance. Choosing the right quantization is about balancing hardware and intelligence. FP8 is the sweet spot on modern GPUs, while 4-bit GGUF models are highly efficient for consumer hardware and laptops. Real-world incidents show that unconstrained agents can accidentally expose ports or leak environment variables. We must treat agent data as untrusted and enforce rigorous security sandboxing. Define clear permission tiers. Use read-only explorers for discovery, supervised modes for pair coding, and reserve full autonomy for strictly designated staging environments with automated gates. Protect your pipeline against prompt injection. Isolate third-party repo content using XML tags. Enforce lock file verification for dependencies, and run automated secret scanning at every ingress point. Language server protocols act as the ultimate ground truth. By running pre-flight checks on code edits in a virtual buffer, you can catch hallucinations before they are saved to disk. Human-in-the-loop checkpoints keep you in control. Approving architectural plans and high-risk operations ensures safety without slowing down your agent's overall velocity. Observability is the key to production reliability. Instrument your agents with OpenTelemetry to track costs, identify tool failures, and replay trajectories during post-mortem debugging. Pipeline Step 1. Define your agent roles clearly. A strong system prompt enforces negative constraints and defines the exact conditions for task completion. Design your tools for reliability. Ensure every operation is idempotent, return detailed diagnostic information for self-correction, and always minimize token usage in your tool outputs. When agents get stuck, use escalating self-correction. Start with compiler feedback, move to LSP symbol analysis, and, if necessary, perform a full rollback to rethink the high-level strategy. Finally, integrate agents into your CI/CD. Trigger them via issue webhooks, run them in isolated work trees, and have them automatically generate documented pull requests for human review.